Hey guys, so in this lesson we will look at the secant segment length theorem. This is also known as, I'm going to write it down, this is also known as secant secant length theorem. So they both would be essentially the same thing. Now before we start, let's take a look at some secant line. Now a secant line is a line that intersects the circle exactly twice. So I'm going to draw a secant line. So let's start to look at this secant line. Now this is a secant line. It is intersecting this circle exactly to a point. So we have, here are the points that we have. We have point A. So this is going to be my point A. Right here is my point A. And then we have point B. Alright, this is point B. So we have point A, point B. First secant. Let's call it line 1. Okay, and then we have secant line 2. So let's draw a second secant line. Here's the second secant line, and this secant line will intercept at exactly twice. So the 2 points that this one intercepts are right here. So I'm going to call this point X, and let's call this point Y. So this is the second secant line. All right, so we have A, B, X, and Y. All right, now the secant segment length theorem states something like this. If we have two secant lines starting at the same exterior point, this is the exterior point, let's call it point P. If that's the case, then there's something special going on about the line segment. And the way it says is, take a look at secant line 1. So take a look at the line 1, which is going to be right up here. This is the line 1. If you look at this line 1, then we have the whole secant times the part of it, which is the extended exterior length, is going to be equal to the whole times the part for line secant line 2, this one. So whole for line 1, the whole secant length is this distance from P to B. That's the whole. Times it by the part. Part is going to be this segment. So let me use this color again. So the part is going to be this was A. Part is going to be this segment, P to A, the one that is exterior, extended length. So PB times PA is going to be equal to the same thing for line 2. So it's going to be PY is the whole, times by, this is P, this is X, this is Y, times it by PX, this portion. That's the part. Alright, so we have PB, so let's use colors now. We have P for secant 1, we have PB, whole thing, times it by PA, part of it, is going to be equal to PY, the whole thing for this segment, secant, times it by PX, which is the part. So that's pretty much the secant-secant length theorem or secant segment length theorem.